Hello, everybody. Welcome to the webinar. We will wait a few more minutes for the people to join. We will wait one more minute to let everybody join, and then we will start. Okay, hi, everybody. Thank you for joining us for today's webinar on Zero Trust Security and the critical role of DNS in it. The session will be recorded today, and we will send you the recording after the webinar. So please take that into account. And I will now get started. So I'm Yael Harel. I'm leading the product marketing for security solutions at EfficientIP. I have over 15 years of experience in the cybersecurity protection domain. I focus on helping organizations strengthen their security strategies with DNS-based defenses. Today, I'm honored to co-host this webinar with Peter Goodwin, one of the leading experts in DNS security. And Peter, I will let you introduce yourself.
Hi, thank you, Yael. So my name is Peter Goodwin. I'm the CSIP director for EMEA with EfficientIP, and I've been working for EfficientIP for the last 4 years.
Thank you, Peter. So today we will start by understanding the Zero Trust model, what it is about. Then we will talk about the role of DNS in Zero Trust security. After that, we will review how enhancing access control with DNS-based micro-segmentation can help with Zero Trust implementation. Then we will look at how proactive DNS threat detection and adaptive response can help with that. We will also see how simplifying Zero Trust with observability and automation can be achieved. And finally, of course, we will leave some time for questions and key takeaways. So let's start by understanding the Zero Trust concept from an example, non-technical example from the real world. So a few years ago, there was a major issue in Poland where visas were being sold for money. So people were given visas without any background check, without any security check, or any regulation as it should be. As a result of that, many people who got a visa from Poland traveled around Europe and outside of Europe thanks to the visa they got from Poland and thanks to the Schengen Agreement. So let's see how this could have impacted Europe. Theoretically, it's not an exact real case study, but just a theoretical story. So let's meet Selina Kyle. She's a thief that wants to enter Europe. She wants to enter specifically France and do some damage in one of the famous museums. She wants to do damage to the Monet painting just because this will help her build her safe reputation. So she wants to get to France, but she knows she can't have any visa because she's already a well-known thief with a record of doing criminal acts. So she will never get a visa to France. But then she sees on TikTok an ad, a publication. This is something that really happened back then, in which she reads that she can get a visa to Poland for about $5,000 without any background check. So she applies for this visa, and she gets a visa, a legitimate visa through an illegal process. Then she travels to France. she travels to Poland using her Polish visa that she just purchased, and she managed to enter Poland. From that point, it's very easy to get to France. She rents a car, she goes to France, and her mission is accomplished. So, of course, this is a very theoretical story that did not happen as it is, or could maybe not happen exactly as it is, just to emphasize the meaning of zero trust, because once you trust a person that is inside the organization, they can move around and do whatever they want in the organization. And now let's take that into a real cyber attack example. And I will start with a little video.
Hackers have infiltrated thousands of internet-connected security cameras that were being used inside schools, hospitals, and several major companies. CBS News Chief Justice and Homeland Security correspondent Jeff Begays reports.
The hackers claim to have breached the feeds of 150,000 internet-connected security cameras, one of which showed this confrontation between hospital staff, security, and a patient appearing to have a medical episode. Other cameras showed what appears to be a hospital intensive care unit, police interrogation rooms, prison cells, community centers for kids, as well as factory and showroom floors of automakers Tesla and Nissan. Till Cotman is part of a group of international hackers claim.
So as you've seen in the short video, this was a major data breach from a company called Bricada. In March 2021, attackers managed to exploit their systems. They managed to exploit the support Jenkins server vulnerability and enter into the organization. And now we'll take a look step by step what exactly happened. So we have the attacker, and the attacker managed to gain admin credentials that were simply exposed out into the internet. They managed to access the Jenkins server thanks to a misconfiguration of this server. And from that, once they had the admin password, they managed to access the support web interface. This is a support system used to help customers that have security cameras to solve issues, improve camera resolution, stuff like this. So it is a support system with some access to the remote cameras of the clients. Then the next step after that, the attacker managed to access the command platform, which allows control over customer cameras. This is already the system that actually has access directly to customers. In this case, it had access to all customers. We will talk about that in how Zero Trust could have helped in this situation. After that, the attacker executed commands on the cameras, not on all cameras, but on many cameras in the incident. For example, they ran some command to try to identify the IP address. They managed to get Wi-Fi password and name and some other interesting information. But the important point here is that the commands were running on the cameras and some traffic went externally from the cameras, which could have theoretically been detected if they had the relevant measures. At the next step, they downloaded footage from around 150K cameras. The download wasn't done directly from the camera, but from their databases, which store the camera, including they also managed to access some live footage, as we've seen in the video. And finally, as all of this wasn't enough, they managed to obtain badge credentials, which means they could have printed actual badge and access buildings, customers' building, and enter and do additional damage. They didn't do it in that case. The attackers claimed that they only wanted to show the vulnerability of security cameras, but they reach a lot of information and they got access to very sensitive information. Now we will demonstrate how Zero Trust could have helped in this attack if it would have been one of the architecture or strategy used by the company. So the first step would have been, of course, to protect the password. This was the entry point of this attack. So a simple procedure like multi-factor authentication would have blocked this attack in this case. And of course, this privilege practice, which would ensure that once the password were achieved, were stolen, the attacker wouldn't be able to do everything that we've just seen. The second thing that is not related directly to the story, because we don't have any evidence of phishing that was done in order to retrieve the password, but this is one of the most common methods to steal passwords and data. We don't know if it was involved in this case, but having anti-phishing protection and advanced engines to detect phishing is also important to protect such information. At the second step, it is very important to prevent the usage of those credentials. In the zero trust principle that we will see in the next slide, we never assume trust. So even if you have admin credentials, and in this case it was super admin credentials, they could access everything. It doesn't mean you need to access everything in your organization, and this is a good example and explanation on why. So they could have implemented measures that would have blocked the attack one step after it started. And of course, network segmentation. There was no reason to give access to the admin for all the footage of all cameras at that point. And they managed to access pretty much everything without any segmentation or by need definition. The next step, when they managed to access the command platform, again, micro-segmentation would have blocked lateral movement here. And another aspect that we can add here is continuous authentication that would ensure ongoing trust verification, which is another principle we will discuss in Zero Trust. The idea is that when someone moves inside the organization, we never assume that it is a verified person, or in this case, it's not a person that moves around, but an attacker. We would have, if we would have monitored the network and continuously verify who's accessing each element, it could have been, the damage could have been mitigated. At the next steps, if you remember, we've seen that the attacker ran some commands on the camera and some traffic left from the cameras to some domains which are not needed for the management of the camera. So granular access control using DNS, which is at the earliest point in the network, would have been able to detect such or to block such an access by allowing cameras to only access their management systems and not to access any other domain. We will see a demo of how this can be achieved with DNS later. And DNS monitoring and user behavioral analysis, which might have detected some anomaly in the traffic to block the attack. At the next step, when the footage was downloaded, again, applying behavioral analysis that would have or could have, maybe, we can't of course promise that everything will be detected in every technology, but this is why we have a comprehensive approach. But anomaly detection of the traffic from the DNS to the internet could have can detect data exfiltration, and it could have detected the footage going to a place that they shouldn't go to. It's not the server in the organization, it's somewhere in the cloud, external source, which is not relevant for them. And additionally, automated response to that detection could have blocked the attack before the footage would have reached the attacker. And what we've seen in the video with all the images and videos from the different cameras could have been stopped automatically. And another point, encryption of the data, of course, would have helped as well. Regarding the last step, where they gained access to badge credentials, in this case, user-based access control would have helped too, because they managed to get information that they shouldn't have gotten. The admin doesn't need to access information such as user and credentials of badges, and automated response here as well would have helped them respond quickly and block all those users that their badge data was stolen from accessing the organization. And if everything would have been deployed as expected in a zero trust model, maybe, but just maybe, the thief would have dropped the attempt to attack this organization and moved to the next victim. So what is zero trust? I talked a lot about zero trust. I said I was introducing zero trust, but I haven't explained what it is. So zero trust, first, it is a philosophy. It's a model of thought and not a tool or a product. It was introduced by Forrester as an alternative to the perimeter security model. Why did they propose that? It's because in the perimeter security model, everyone inside the perimeter is trusted by default. But perimeter security is no longer enough. As environments become more diverse and hybrid, we have environments combining cloud and on-premise. We have remote workers. We have IoTs. So we can't use anymore the past paradigms. And with zero trust security model, everyone is untrusted by default, even if they are already inside the network. All access requests must be verified, and users are only allowed to proceed if they are explicitly permitted, which means that in this case, it's a really good example of that, because the admin, it's not that the admin did something that he shouldn't, besides maybe using too easy passwords or exposing the password, but it's not that the admin is someone who shouldn't be trusted, but someone took over of his credentials, and thanks to the credentials managed to move inside the organization, and a zero trust approach can help reduce such incidents. So what about DNS and its role in the zero trust security? Let's take a look at that. So first, let's start with a few reminders about what DNS is about. So DNS is the entry point for every organization. It is placed as an early checkpoint that can be leveraged to perform checks at a very, very early stage of the attack. The DNS routes internal and external traffic between users and applications, which means that we see a lot of traffic through the DNS, and it means that the DNS offers visibility over the network traffic and the user at the user level. We will see some examples of how we leverage that information into technologies of detection, visibility, automation. This is all thanks to the fact that it is located in a very critical place at the organization. And at last, DNS holds data about the behavior and intent of the users in the network. So it can so by using the data in the DNS, we can understand what's going on in the network and detect anomalies, which are indication of attacks. And having that in mind, let's have a look at what network and security teams say about the use of DNS in zero trust. This is coming from a 2024 EMEA survey on zero trust, which surveyed 270 companies in the US, Canada, and Europe. And all respondents mentioned, as you see on the screen, that DNS has an important role in zero trust implementation. It can be helpful in policy enforcement. It can be helpful in reducing attack surface with secure DNS solutions, and so on. I will not go through all the details. You can see the report in our website if you want to learn more. And now we will talk about the four main use cases where DNS can help you with your zero trust networking strategy. And Peter, I will hand over the mic to you.
Thank you, Yanni. So, I mean, these are the four kind of tenets of zero trust, and DNS fits in to some extent in all four of them. I mean, the fact that for never trust, always verified, DNS, as you mentioned before, it's the first kind of part of any network transaction typically. I mean, I think over 90% 99% of all transactions start with a DNS request, because we don't generally remember IP addresses, but we remember names. So actually having the DNS request to start with gives you a perfect opportunity to apply some security profiles at the very beginning of the transaction, rather than waiting for something to actually start. So by default, you could just deny all DNS requests and no one will be able to do anything. But if it's a validated request, you can then authorize someone to proceed in what they're doing. And the least privileged and default deny aspect of it is an interesting one, because typically when you're inside a network and you make a DNS request, you get an answer. It's almost like picking up an old phone book for people back in the day, finding out what the information you want, and it's freely accessible. Everything's in there. If we actually want to start controlling what people access, then you could start to say, well, okay, you only get access to the things that you need to do your day job. And you start with no privileges, and then you increase what people are allowed to do as they go along. The full visibility and inspection is key, because you can't really secure what you can't see or don't know about. So being able to look at what people are doing with DNS on a day-by-day basis, and actually look at individuals and look at the behavior of those individuals, gives you a little bit more ability to control what's going on. And it's a truism that mostly people just ignore DNS day by day. There's so much data that's generated because there are so many queries that are generated across a network. It's a very difficult task to go through and analyze that in near real time, or even just after it's happened. So no one really looks at what's going on with DNS unless there's an issue. Forensically, people will go back in and look at things that happened when an event occurred. But generally, if it's working, people leave it alone. And then centralized management's key, because typically people have more than one DNS server running in their network. And if you want fine-grained policies to be pushed out to the edge where the DNS servers are, so that you only have authorized users and devices that have access to certain resources and applications, having centralized management of that becomes very key. If it's all distributed or dispersed and there's no common view of it all, it's very difficult to coordinate what you're doing from a security perspective. So centralized management is probably a key thing as well. And in the future slides, if you want to move on, Yeli, then we'll look at how we do that with our security. So enhancing access control with micro-segmentation. What do we mean by that? And as I kind of mentioned earlier, if I'm on anyone's network and I make a query on someone's machine for a valid DNS name in a valid DNS zone, I would almost put money as a betting man that I will get a valid response. So if I put in the name and I want the IP address, I'll get the IP address. Typically, the question I ask customers is, should I? Should I be able to access any name in any valid zone? Because I might not have the right to access a particular system, but I might get the name and the IP address, which is two pieces of information I didn't have before I made that query. So what we can do is we can start to control access by looking at filtering based on allow and deny lists. So this, not just looking at the destination name that the client is querying, whether that's internal or external. We can all check against known threat actors by consuming threat data on a DNS server, And every query we can check against all those entries. And if they trigger, we can do a number of things. We can rewrite, we can block, we can do whatever. But when it's a valid name, it doesn't trigger any security rules typically. So if we want to start looking at controlling access, well, one, we need to be able to identify the user that's making the query. And then we also need to consider what the destination is. And with the combination of either allowing or denying access, you can start to apply very granular security controls at the DNS level to either stop people being able to access particular names or just restricting them to only being able to access one or two names. And there's a number of use cases that we'll come on to that we actually go through this. Do you want to go to the next?
Yeah. So I will now, thank you, Peter. I will now show an example of what Peter just explained with the use case of IoT devices and how we can manage the access of those devices. So in the center, you see our client query filtering feature, which is the implementation of the technology that Peter have just described. And the first step is we will have a multiple list, a client list and domain list, which are defining what the user is allowed, which clients are allowed to access which domains. With a simple example of the laptop. So in this example here, the laptop is authorized to access all the apps that are allowed. It's just for the sake of this example to explain what happens with an IoT device. So once an IoT device is connected to the network, it will be identified automatically. Once it will be identified, the client list will be updated with an entry saying this client is an IoT device. An IoT device is only allowed to access the specific IoT management applications which are listed in the domain list. So once it tries, I will go back to show this. Once the IoT device tries to access a domain, an application that is defined as an IoT application, it will succeed. It will be authorized. But when it tries to access, or when it tries to access anything else, it can be a search engine that this device doesn't need to access. It will be denied. And we will now see exactly this in a demo of the product. So what you see here on the screen is the DNS Guardian dashboard. And the first thing that we will see is the list of domains and the list of clients. So we have here, for the sake of the demo, only two lists, one list of domain and one list of clients. And just to give you the idea of how a domain list looks like, let's take a look at list one. It has, of course, the domain URL. It has relevant tags. You can see that it can have different tags for each domain. You can tag them automatically based on a feed, and you can tag them manually as you prefer, and you can combine the two, of course. And you have a list of clients, which has for each client the tag of this client, the zone, and some other criteria that you can define. Now we'll take a real quick look at the tags. So in this example, we have tags, attack type tags like DGA, malicious, malware, and we also have tags that categorize by type of device or type of domain, like the IoT. This is also something very granular. You can tag automatically using a feed like the EfficientIP DNS threat pulse, or your own feed, and you can tag it by defining your own tagging policy. Now we'll take a look at the rule set. So in this example, we'll take a look at a rule set that contains 3 rules to simplify the demo. And as per the zero trust principle, the first rule will always be local, because by default, no one should access anything unless we specifically allow them to access it. We will now see how we activate this rule. I will skip this rule definition. And in this screen, what we see is a script that we've created just to illustrate real traffic. And we will see that once we activated the block all, the traffic, all the different queries will be blocked. So we can see that everything was blocked as expected. And the next step, we will activate the rule that allows IoT devices to access IoT domains. We will see how it works. So this rule combines two different definitions. The first one is the IoT one. There's the IoT tag. And in this command, what we define is that clients that are tagged in list 1 as IoT can access domains, clients that are tagged in list 2 as IoT can access domain tagged in list 1 as IoT. So this is, of course, a very simplified way to show in the demo, but you can define very granular rules per your needs. The second match that we have in the same rule is that every client in the organization can access search engines as a baseline. So this is where we move from blocking everything to defining what each client, based on their type, is allowed to do. Now, after that, we will activate this rule and we will run the traffic again. And we see that in this case, you can see here that these are IoT devices, the two last ones, and they are accessing domains that were tagged in the list as IoT domains, and their traffic passes through. And the same for the search engine. In this case, it's a Google point FR. All clients, including the IoT, access those domains because this is what we define in the rule base. The second area where DNS can help with zero trust security is with proactive DNS threat detection and adaptive response, which is an important combination that allows detecting threats and reacting to them very quickly or very early. The foundation for our detection capability lies in the DNS transaction inspection, or we call it also DTI, which offers granular visibility and analysis of internal enterprise DNS traffic. So if you remember, we've mentioned before when I explained what the role of DNS in the network is, one of the key elements was that we have in the DNS very important traffic, and as part of it, we can see the internal traffic. An inspection of the transaction can give us a lot of insights regarding what's a normal transaction and what's an anomaly or a suspect for an attack. And on top of this DNS transaction inspection, we have a user behavioral analysis, which analyzes the client behavior and detects threats based to that. So it can take a look at one client or a combination of several clients and the way they communicate through the DNS protocol, and to see that something is not normal, and by that detecting attacks, which is a very good place to detect attacks because it is at a very early point in your network. On top of that, we have some advanced detection technologies that with evolving of cyber threats and the fact that they become very sophisticated, and attackers have several methods, many different methods to execute their attacks, including using AI to develop attacks. It is very important to be ahead of the attackers and develop technologies for detection. So to complement what I've mentioned before in the Guardian side, we have in the Threat Cloud platform detection of advanced threats. I will give here 3 examples. The first one is phishing detection, in which we use NLP, natural language processing, and image recognition to detect phishing attempts and block them at an early point. The second one is domain behavioral analysis, which is very important for zero trust because it can detect data exfiltration. We look at the traffic going from the organization to the internet, and we identify some unusual patterns in the domains. For example, if a domain suddenly creates many subdomains, and we see many clients communicating with those domains, we will understand that something suspicious is happening, and maybe it is being used for stealing data. And the last one, the DGAs. So DGAs are often used by attackers for their communication, for the CNC communication, and for data exfiltration. So detecting DGAs is another important aspect of detecting data breaches, for example. And for that, EfficientIP has developed an innovative tuple clustering model, which you see in the image here. I will not go into the details today about that, but it detects the most advanced DGAs sometimes months before the DGA becomes active, and therefore blocking it at a very, very early stage. We have another webinar that we did a few weeks ago about that. If you'd like to watch it, you can find it in our website. And to complement the detection, detection is important, but it's also important to react once you detect a threat. And for that, we have adaptive countermeasures, which are basically automation for the response, for the incident response. You can define your own actions based on what's happening and based on your own policy in the organization. So you can block the traffic, you can redirect traffic, you can decide to quarantine a client, which is a patented technology that allows you to, once we identify a client that is probably infected based on the behavior, you can decide that you automatically quarantine it in order to later check it and decide what to do it. The second aspect of incident response, which is as much important as automated response, is the DNS intelligence and analytics, which is very, very important when you have an incident like the one we've seen in the example at the beginning of the webinar. One of the positive points that we can say about Verkada, they responded very fast to the incident with the footage that were leaked. They notified their clients immediately about the incident and managed to contain it. And having DNS data intelligence and analytics can help you do that once you have an incident. The last aspect that can help you simplify zero trust in DNS is the observability and automation. And for that, I will move back the mic to Peter.
Thank you, Yanni. So yeah, DDI observability, and if you look at zero trust and where organizations are actually trying to implement it, you kind of need the visibility into what's going on across the network, but really with DNS, so that you can help detect where threats are occurring, you can enforce policies, and you can just make sure that you're continually verifying people in the network. And there's a number of key ways that DDI specifically can help with this. I mean, the first thing is looking at baselining normal behavior. And it's a truism that, again, people don't really look at what's going on in DNS day by day. So having some method of being able to see what's going on in the DNS and reacting to anything that is not normal. You know, we talked about looking at how you restrict or monitor people or devices querying for names that they probably shouldn't do. That helps with the observability. Looking at things that indicate lateral movement, data exfiltration, or even being able just to see what's going on with the DNS, the servers themselves, by monitoring the DNS and the network metrics, to look at things that might indicate you're under attack. There are attacks that are targeting DNS servers to starve them of resources. Sloth attacks is probably the most insidious of them, where attackers will make a series of queries that are designed to take a very long time to get an answer from the internet. They don't make an error. They are valid requests. They result in a valid answer. They just use resources while they're waiting. And if you send enough, you can start to stop the DNS server from actually accepting any other queries. And that doesn't really look like an error when you're trying to see what's going on. The recursivity goes up, various other things, but it's very difficult to see that it's actually an attack. It just looks like DNS servers struggling for CPU. If someone's doing lateral movement, then they're going to make reconnaissance query requests. So understanding that that's happening. Looking across the whole thing to try and see where there's any issues in any particular network, whether it's in site A, site B, site C, wherever it is. So having end-to-end visibility across all of the DDI infrastructure. And then collating all these metrics into one place so that you can actually then react to them. And that's what we do with our DDI observability. And then from there, we want to start talking around what we can do from an automation side. Typically, this is providing the building blocks that you can interoperate multiple systems together. So wouldn't it be good if a threat does occur and you know the IP address that it's targeting, that you could tell a firewall to block traffic to that IP address? And to do this kind of stuff, one, you need to have a reasonably good discovery tool to start building the network single source of truth. Because if you're going to actually automate things, you want to be doing that automation with good data. It's no use just looking at an Excel spreadsheet, trying to pull an IP address of it that you don't know that's in the network for sure, and then doing something with it. So having that network source of truth starts to enable the ability to automate things. Having the open APIs and plugins so that you can talk to third-party applications and platforms. So if you've got ServiceNow and you want to automate creating IP addresses or registering the IP addresses, and then having a DNS name created for the service that you want to bring up on that IP, and doing that automatically so it's available the moment the IP is registered. And then when you remove a service and you want to clean all that up, is to delete the information that's there as well. And if you need DHCP pools or fixed addresses created, doing that as part of the life cycle of the service you're bringing up. So specifically around zero trust, integrating with a NAC service so you can tell the NAC to block a particular user or particular IP address. Integrating with SIMs and SOARs so that when an event does trigger a security event within the DDI, you can tell the SIM and the SOAR relevant information. The security guys can then act on it. And a lot of the times where customers aren't actually blocking or rewriting the requests that have triggered a DNS security event, even just telling the security guys via the SIM or the SOAR that something anomalous has occurred is enough for the security guys to be aware of something. And again, they can't secure what they can't see. They don't know about it. There's nothing they can do about it. So actually having that network automation hub enables the IT teams to be able to view what's going on, be able to connect systems together to get better value from the infrastructure they've already bought, and automate a lot of the security profiles and aspects that they need, just so that it's enforced everywhere and anytime. Is that okay, Yelena?
Thank you, Peter. So we're getting close to the end of the session. We've covered today how zero trust security can be strengthened through AI-driven threat detection, adaptive countermeasures, DDI observability, and network automation. To wrap up, let's go over the key takeaways from today's discussion, and then we will answer your questions. So DNS helps you in the 3 steps of the attack. It helps you proactively protect before you're being attacked, which is very important for zero trust security. It helps you early detect an attack once it entered the organization and block it at the earliest possible stage. And it helps you eventually also to effectively respond, as we've seen in the last few discussions. And the key takeaways from today can be tied up to the 4 elements that we've shown before, 4 use cases in which DNS security can help you with your zero trust strategy. I will not repeat everything we've already said, but the idea is that really to maintain the security level required for zero trust at the different steps of the different aspects of the network. Now, before we really finish, we just want to remind you a little bit who EfficientIP is, in case you don't know us. And I will give back the speaking to Peter.
Okay, thanks, Yeli. So obviously we've been talking around zero trust and DDI, so I think that it's fairly self-explanatory that we are a DDI company and we do act as a kind of a global leader within that realm. We operate around the world in over 100 countries. We have offices in our HQ for North America is in Philadelphia, in EMEA it's in Paris, in APAC in Singapore, and we've got over 1,000 customers worldwide. And the analysts look at us as one of the leaders in the field. I mean, the whole point of EfficientIP is to make networking simple and secure for everywhere and to deliver the best user experience at all times. That's why they formed the company at the start. It's why we do what we do every day.
Thank you very much.
And we have some questions, Yeli. So
okay.
Question number 1 was, how well does this type of technology interoperate with Active Directory, which is so deeply integrated with DNS? And I think I can answer that one in that for a lot of what we've talked about today, DNS on Active Directory really doesn't do that. It comes with Active Directory. It's essentially free from Microsoft, but you do have to then pay to maintain and to run it. A lot of what we see with our customers is migrating away from Active Directory DNS to running it on EfficientIP's DNS servers. And if for the zero trust part of what we've been mainly talking around today, that tends to be the more recursive function, the caching, forwarding, recursive function of DNS. The authoritative data you can still leave on Active Directory. From our perspective, we can manage that in either a read-only or as a control point if needed, but you can leave the authoritative data on it. You can also move it onto EfficientIP, and we support what's needed for AD. But typically, if you want to do the zero trust, the micro-segmentation, you need that recursive function to run on EfficientIP. Hopefully that answers question 1. Question 2 was, how often are these lists updated and who is double checking them? Well, there are 2 sets of lists essentially we can talk about. From a micro-segmentation, the allow and deny lists are very specific to an individual customer environment. And typically the people that are managing the DNS day by day, so the ops team, whether it's a NetOps, NetSecOps or whatever, they would be the team that would look after the allow and the deny lists because they know the names and the users that you want to control. Where it's consuming threat data, you can consume third-party threat data on our platform. That's not a problem. That would be the third party that maintains it. For the feeds that we produce, and we have quite a few feeds, it's a team in Paris that curate those feeds. and they're constantly curating it to make sure it's low false positives, and they can be updated minute by minute, depending on what level of support you want and how often you want those updated. Question 3, the largest issue we have is bring your own device environment. Are users not using our DNS servers? We are moving to a more managed device environment for employees, but still run into DNS over HTTPS/TLS. Are there guidelines on environmental setup? Day one guide to set up the network to leverage all of this. Typically, if we were looking at deploying into a customer network, our professional services would handle most of the migration and the actual building out of the solution. But if we're talking specifically about configuring users to use HTTPS/TLS to access the DNS servers all the time, there's a number of things you can do with that. I mean, our DNS servers will natively handle HTTPS, DOH, DOT, but sometimes you might want to just put a proxy in front of that to handle the encryption and decryption and offload that from the DNS server, which is, again, that's entirely possible. We do have some guidelines on how to do that, but it's generally customer specific for the way that they want to organize it. If you are managing the devices, you can enforce the DNS servers they use. So it is possible, but it is generally a specific customer implementation. Question 4, could DNS blacklists get added as well? Yes, typically most implementations where you are either using threat data or micro-segmentation, you would have both a whitelist and a blacklist. You'd normally order it for the whitelist first, so that if anything is in the whitelist, it just always gets answered. Then have your own private blacklist, and then any threat data, any segmentation that you want to do after that. But you can reorder the feeds and the lists in however way you want. And then question 5 is, how does it interact with DNSSEC? Well, from a recursive viewpoint, you can use DNSSEC validation on the recursive side, so that any external name, we validate that the response we get is a valid one using DNSSEC. DNSSEC for an authoritative doesn't really get touched within this because it's the name you're looking at for any segmentation, and the blocking comes before that recursive query goes to the authoritative server, and it's the authoritative server that would answer with the DNSSEC records as well. But from a recursive point, if you want to validate any recursive query against DNSSEC, that is after the name has already been decided whether we're going to try and recurse it or not. And then complementary to question 4, going back to the blacklists, are the blacklists included or need they to get licensed separately? The DNS file with EfficientIP is built into the product, so the blacklist, whitelist functionality is in there in the base product. So no, you don't have to license them separately. And then question 6, would this solution help to triangulate the source IP address and user during an incident breach investigation? It's an interesting one, because to do that you need to log every single query typically, and that gets problematic with the large volume that you can get. What we tend to do is we look at where the threat gets triggered. So if it's against a particular threat feed, or if it's an allow or deny list and the micro-segmentation that's throwing the error or the event, then yes, we will log the source IP address and we log the name, and that will be sent through to the SIM so that you can then see who had the IP address at that time. I'm hoping that that's answered all the questions. If there are any more as they come in, no more questions. Okay. I
And if
think
you
I've
have
answered all of them.
any, thank you, Peter. And if you have any further questions, you can send them to us, and we will answer, of course, offline. So thank you very much.
Thank you. So I think we can close the session and stop recording, and then everyone will get the ability to download the deck plus view the recording if they want to. So thank you for your time.
Thank you very much.